Okay, you guys may begin your quiz. Your quiz is online. Okay, so go on now. Do me a favor if you can, before you click on the link, mute your, or just, no, actually, I don't want you turning off your video. I want to be able to see you guys. All right, that's fine. Just give me a thumbs up when you guys are all done.
Oh, where do we find the quiz?
It's on Portal. Okay, it looks like we've got everyone. Okay, so let's get started. Okay, so this is definitely a quiz that I want to go over with you guys. Okay, now let me share my screen. Okay, so, and pardon me for my really bad annotations in advance. I want to let you guys know that. Here we go. Let me share my screen. Okay, so let's take a look at this first equation. Okay, let me get rid of this. All right, let's take a look at this first one right here. Okay, now I have consider the following condition: precondition x is greater than 0. Okay, now this is what we would call post recursion. Okay, this is actually the easiest of all the recursive type of questions, and the reason why is because you're not storing anything. Okay, you're not storing a thing, right? If x is greater than y, so we have 2 is greater than 7. System.out.print x. Now here's the thing: the print statement is coming before the method call. Okay, it's coming before. Therefore, 2 gets printed first. So right off the bat, because I know that it's 2, okay, because I know that it's 2, I can eliminate B and I can eliminate D, right? Then I call on it with 3. Now I know that I'm eventually going to hit 7. I don't have an equation that is false, so I can eliminate E. Okay, so it literally just comes down to this. So it's going to 3, 4, 5, 6. But here's the caveat: it's not less than or equal to. It's just less than. So this will never print 7. So the answer is 2, 3, 4, 5, 6. Okay. And again, recursion, this one, it's not storing anything. These are the easiest ones because all it's doing is just calling on the method again. What is this method doing? Simply printing something out. Okay. All right. The second one. Okay. Now this one is pre-recursion. This one actually is pre-recursion. Okay. So in this one, you actually are storing something. Okay. So in this one, I have method 1602 x plus 1 y, but then I have a print statement. Now I always start off with my first x value. So I know I'm going to have 2. So what gets stored is 2, 3, 4, 5, 6, and then finally 7. But here's the problem. Okay, but here's the difference. This one uses LIFO because you're actually storing data last in, first out. So the thing that spits out is 7, 6, 5, 4, 3, 2. And the caveat here is that it's an x is less than or equal to y. So 7 is actually going to be stored. Okay. Now, the last one here, okay, this one is 11. Okay. So public static int method 1606 int n. If n is equal to 0, return n. Else if n modular 2 equals 0, return n plus method 1601. So basically, if it's an odd, what you're doing is you're storing. So here's the thing. You're basically building a super equation. Okay. Not a super equation, but basically you're building just a long algorithm because you've got to remember that you're not only storing the n, you're storing the n and the process. Okay. So when you go 10, the first thing that's going to be n modular 2 is going to be 10 plus, and then what will be, and so then it's 9. Okay. Then it would be 9 minus. Okay. So 10 plus 9 minus, et cetera, and you will work your way all the way down until you get to 0. Okay. And when you add and subtract all those numbers, you come up with 11. Okay. And again, what you want to do also is, even though you should still get the same answer, you're working your way back up. So as you're building your chart with your pluses, and what I like to do is when I'm building my chart, what I like to do that kind of helps me whenever I'm doing something, an equation like this of recursion, what I like to do is this. I'm just pulling up like an empty Word document so my annotation shows up a little better. So what I like to do is, okay, and annotate. So what I personally like to do is I'll do this. Okay. All right. So I just say 10 for 10, what gets stored for n. Okay. So if n is 10, and then this is the process. You guys get it. Okay. So what would be stored would be 10 plus. And then the next one would have been 9 minus. So as I'm working my way up, I've got my equation as I work my way back up. Okay. So that was the quiz. Okay. It wasn't too difficult for some of you. Again, I think the issue again that some of you guys are having is post-recursion versus pre-recursion. And again, pre-recursion is where stuff gets stored. The recursion happens, whether it's the process or anything like that. Post-recursion, nothing, those are the easiest questions. Post-recursions are the ones where everything just gets spit out automatically, okay, just by default. Okay, so let me open up Eclipse. Let me show you a question that I had that I was doing with my other class. Kennedy, yeah, question.
How do you know when to reverse it and when not to?
What do you mean?
Like when it prints, how do you know when it reverses and when it doesn't?
Okay, so the key thing, so let me just pull up this. So share screen on the quiz real quick. Okay, so in this instance right here, we'll go up to here. Okay, if the print statement or any X value or something like that is spit out before you call on the recursion and nothing comes after it, okay, that's when you know you're not storing anything. Okay, when it's simply a method call. Okay, whereas here, same question, but all I did pretty much was switch this salient feature and move the print statement afterwards. Well, the recursive call is happening before the print statement. There's still stuff that comes after it. In that case, I've got to store it for later use. And in that case, that is when last in, first out takes over. Okay. So let's take a look at this problem right here. Okay. I've got this problem right here. Okay, let's analyze this. Okay. Now, I specifically put this question out because, so let's take a look at it this way. Okay. Okay. What is going to print out? What type of recursion is this?
Recursion?
Post. So in terms of post, it happens after everything else is done. That's what it means, post. Okay, last thing. Pre means it happens before there's other things that are going on. Okay, so in this instance, if I analyze this equation, okay, I've got, so dot, then let's say, so for example, let's say I did method 1606 4. Okay, so I would get, so if as my best, my break cases, my break statements are 0, okay, or base cases, sorry, 0 and 1. So if when it gets to 0 or 1, okay, we can stop. That's when we're good. Okay. So if we take a look at this one, we system.println dot. So period, we're not storing anything. So then I run it again. Period, I run it again. Period, I run it again. Okay. And then I finally get to 1 and it's an asterisk. And then I just spit out the asterisk. So it should be dot, 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 asterisk. Okay. Nothing is stored at all. Okay. But then I add this line. Now, not only do I have post recursion, I have pre-recursion. Okay, I have post and I have pre. All right. Very interesting. Okay, so I have post and I have pre-recursion. All right. So analyze this question for a minute. Okay, I'm gonna get some water. I'll be right back. All right. Okay, so let's take a look. So how many of you think that this is going to be dot dash? Okay. What, let me see. Armand, what do you think this is going to print out?
Will it print out? Will it be dot dash dot asterisk?
Dot dash dot asterisk. Okay, that's one. Okay, anybody else? Yes, Benny.
Would it be like, I don't know exactly, but I know like the process, there will be more dashes every time you run through, like sandwiching it. Like
I think
basically
like,
more dashes every single time you go through.
no, well, no, it's not a nested for loop. It's not like increasing in value. There's no increasing. It wouldn't do any of that. It wouldn't just call it again. Okay, it's actually a lot easier than you think it is, guys. So when I break this down, okay, what's happening is this. Okay, dot. So if I were to do this, let me just annotate here. Okay. All right. So, okay, basically what is happening on the first call. Okay. What's being printed out and what's being stored are two different things. Okay. Printed and stored. Okay. So the first thing that's being printed is the dot. The dash is stored. Then the next thing that's being printed out is another dot. Another dash is stored. Then a third dot. Okay. Then another dash. Then finally I get to 1. Okay. At 1, I print out, oh, sorry, I print out the asterisk, okay? Then this one comes out, this one comes out, and this one comes out. At that point, I can start spitting out everything that I stored, okay? So if I run this, I get ... asterisk ///. The asterisks are being stored. And technically this asterisk was the last one that I stored. Whereas this one was the first one. Okay, because once I get to this asterisk right here, at this point, the computer is telling me, okay, I need to release everything else that I was storing. You're not doing any recursive calls, spit it all back out. And that's how it's working. Okay. All right, does anybody have any questions regarding recursion? Okay. Pre and post recursion. Now, again, what we're going to do is tomorrow we'll probably go over some AP problems. Okay. And we'll go over just a little bit more. I know recursion can be a little confusing, but like I told you, this is one of the two more difficult topics. But once you get it down, it really isn't too difficult. Okay. Anybody else have any questions? Okay. Now, how many of you thought the quiz was actually difficult? How many of you, now that you kind of understand it, feel like you would do a little bit better if you now after kind of seeing this? Okay, I'm not promising, I may give you a double or nothing quiz, okay, tomorrow, just to see. So for example, if any of you got a 1, let's say that I give you a quiz and you get a 3, then I'll overwrite the 3 or the 1 with a 3. Maybe I'll think about it. Okay, no promises, but if I do it, obviously I'm going to use much harder questions. Okay. So that being said, guys, believe it or not, I'm actually in Joshua Tree. So I'm actually getting ready to leave back home right now. Does anybody have any questions regarding recursion? Because this is basically, so just to give you guys also heads up, this is all we covered in the last class as well. Okay. Hold on one second, guys. Okay. All right. I'm back. Sorry. Okay. So this is all we covered also on Friday, is we just went over recursion, but they were a little bit more confused than you seem to be. There was a lot of questions on recursion and stuff like that, and they didn't understand that example. Okay. So we have the time. Does anybody have any questions? Yes, Kennedy.
For the quiz question with the adding and subtract, the answer was 11 for that one.
Correct.
Instead of doing a chart, I made like an equation, and that got me the wrong. When you make the chart, if you're doing like the plus and minus, does it come after or before the number? Because I was putting it
after.
Okay.
It would be 10 plus.
Okay, because I did the opposite.
So do me a favor, send me a picture of your work so I can see it.
Okay.
Because if you plug this in to Eclipse, it's 11. And I had it printing out each end that was being subtracted and stored. I did it, but for some reason, when I wrote this equation, the dash or whatever, I deleted it and I didn't save it. So I can rewrite it, and I'll put and we can go over that really quickly tomorrow so you can kind of see what is happening with everything.
Just out of curiosity, Kennedy, did you get 5?
Yeah, I did.
Okay.
Okay. All right. Any other questions? All right. Then I will see you guys tomorrow. Okay. Stay safe, guys.